Good morning everyone. In this video session we will learn the ICR of a rolling disc or the wheel. So refer this first problem. A wheel of diameter 0.4 meter is rolling without slipping such that its center has a velocity 10 meter per second towards right. Find the angular velocity of the wheel and also find the velocity of the points Q and the P which are located on the disc or the wheel, and the length Cp is given as a 0.15 meter. Okay, so to solve such type of problem, that is the problem of the disc or the wheel, we have to first locate where is the ICR. So for the disc or wheel, the ICR, which is the instantaneous center of rotation, is always located at the contact point with the ground or with the surface. Okay, so just consider this case. So this is the disc or the wheel and this is the ground. So suppose the wheel is rolling on this ground like this, then it has two types of motion. One is the rotational motion and second it's a CG or the center, it is moving along this direction. So this is the translation. Okay, so this rolling motion, it is the combination of translation as well as rotation. Okay, so for such type of motion which is the combination of translation and the rotation, this is called as a general plane motion. Okay, and for the general plane motion we have to locate where is a ICR. So for the disc, the ICR is always located at the contact point with the ground or with the surface. Okay, now to locate the ICR for the disc, draw the given diagram, that is a circle. Then draw the surface on which the wheel is rolling. Okay, now this contact point, this is the ICR. So name this point as I. Now this is the center point, so point is C. Now what is given in the problem? This center has a velocity of 10 meter per second towards the right. Okay, so velocity of each point on this wheel, it is perpendicular to the line joining the ICR point. Okay, so if I join the point C with the I, then velocity of C is perpendicular to this line Ci. So this is the velocity Vc. Okay, if I consider the second point, that is the point Q, now to find out the velocity vector for the point Q, first join this Q point with the ICR. So this Qi, it will become radius, and the velocity, as Vc is towards right, it means the Q has a velocity towards right, but it is perpendicular to this line. So this is the velocity of the point Q. So this is a Vq. Okay, so in this way we can show the velocity vector of different points on the wheel. Now if I consider this point P, so this is the position of the point P. Okay, to find out the velocity vector of the point P, first join point P with the ICR. Okay, now velocity of point P is exactly perpendicular to this line. Okay, as these two velocities, they are on the right, it means that the wheel is rolling in the clockwise direction. So this is the angular velocity of the complete wheel. Okay, so velocity vector of Vp, it is perpendicular to this line, that is line Pi, and this is the direction of the velocity vector Vp. Okay, so for the wheel, first we have to locate the ICR. So whenever the condition is without slipping, the ICR is exactly located at the contact point with the ground. Okay, then next join this point, that is ICR, with the given any point on the wheel. Okay, so right now the points are given as a C, next is Q and next is P. Okay, Draw this line and then show the velocity vector perpendicular to this line. Okay. Now consider the point C first. Okay, that is a velocity Vc. So we have the basic formula V is equal to R into omega. Now when we consider the point C, the velocity will be Vc. Now this radius will be distance of C with respect to the ICR. So distance Ci into this omega will be omega of this wheel. Okay, so as this wheel it is rolling in this direction, so it has angular velocity omega. So this is the omega for the wheel. Now here Vc is given in the problem. So center has a velocity 10 meter per second. So this is the linear velocity. So Vc, this is 10. Distance Ci, so here diameter is given, which is 0.4. C point is the center, so Ci it will be the radius. Okay, so as the diameter, this is 0.4 meter, so radius this is equal to 0.2 meter. Okay, so Ci will be the exactly radius, so this is 0.2 into omega, and from this omega is equal to 10 upon 0.2. So this is equal to 50 radian per second. Okay, so this is the angular velocity of the wheel. Next we have to find out the velocity of the point Q. Okay, now consider the point Q. So we can write Vq, this is equal to again R into omega. Now omega is the same because all the points they are lying on the same wheel, so omega will remain same. It is a 50 rad per second. Just we have to find out this radius Qi. Okay, now for the point Q, radius will be distance Qi. So this is Qi into omega. So this is the velocity Vq. Okay, so this is Qi into omega is of 50 rad per second. Now our aim is we have to find out the distance Qi. To find out the distance Qi, consider this triangle QCI. Okay, so in this triangle, this CQ it is equal to the radius, Ci is also radius. So then we will find out this Qi. So consider this CQ, this is equal to 0.2 meter, Ci is also 0.2 meter. So Qi we can find out by using Pythagoras. So this is Qi square, this is equal to 0.2 square plus 0.2 square. Okay, so we can find out the Qi. So Qi is equal to 0.2828 meter. Okay, now put this value in the formula for Vq, which is a Qi into 50. So Vq is equal to 0.2828 into 50. So Vq is 14.14 meter per second. Okay, and the last is we have to find out the velocity of the point P. Okay, so to find out velocity of P, the equation will be velocity Vp, this is equal to radius into angular velocity omega. Okay, so omega is same for all the points. For P, radius will be distance P to I. So we can write here distance Pi into omega is of 50. So this is Vp. Okay, now our aim is we have to find out the distance Pi. To calculate distance Pi, consider this triangle PCI. Okay, so in the triangle PCI, distance Cp it is already given. So it is 0.15. So this is 0.15. Distance Ci is nothing but the radius. So this is 0.2 meter. So this is the radius. Okay, so we have to use here sine rule. So sorry, cosine rule. So we can find out this Pi. So two adjacent sides are known and this total angle is also known. Okay, so you can see the original diagram. This angle is 40 degree. So this total will be 90 plus 40. So this total is 130 degree. Okay, so this total angle is 130, 90 plus 40. Now use the cosine rule. So by using the cosine rule, So cosine rule is, unknown is a pi, so pi square, this is equal to, first is cp square plus ci square minus 2 into cp into ci into cos of angle between two known sides, so it is cos 130. Okay, now put the value of cp ci, so this is 0.15 square plus 0.2 square minus 2 into 0.15 into 0.2 into cos of 130. Okay, so if you solve this, we will get the answer for pi. So pi is equal to 0.3179 meter. Okay, so this is the radius for the velocity Vp, that is the distance Pm. Okay, now put this value in this equation. So this is equal to 0.3179 into 50. So Vp is equal to, it is 15.895 meter per second. So this is the velocity of the point P. Okay, so in this way we can find out the velocity of any point on the wheel if we know the location of ICR. Okay, so always remember, if the wheel is rolling without slipping, then ICR is always located at the contact point. Okay, so it may be contact with the ground or contact with the wall. Okay, always the contact point is the ICR point. Okay, now refer this second problem. So in this problem, a wheel having the radius 0.75 meter is rolling without slipping to the right. Determine the velocities of the point P and Q if the center has a velocity 10 meter per second. Okay, so here velocity direction is given. The wheel is rolling in the clockwise direction, means towards right, it means wheel is rolling like this. Okay, it will have some angular velocity omega. Okay, so as the wheel is rolling on the right side, means clockwise direction, its a center has a velocity 10 meter per second. Okay, so first we have to show what is the direction of the center velocity. Okay, so draw the given wheel as it is. Okay, then as the condition is without slipping, it means the ICR, it is the contact point with the ground. So this point is the ICR. So this is the point I. Okay, next, this is the center point. So take this point as a C. The velocity given 10 meter per second, it is for the center. Okay, now the direction of velocity, it is always perpendicular to the line that joins the ICR and the given point. Okay, so velocity of C is perpendicular and it is towards right because wheel is rolling in this direction, means velocity vector must be on the right side. So this is the VC. Okay, and it is perpendicular to the line CI. Okay, next we have to find out the velocity of the point P and velocity of the point Q. Okay, so to find out velocity P, first join this point P with the ICR and then draw the perpendicular to this line because this is the radius vector. So this is VP, and similarly join this Q point with the ICR and draw the perpendicular velocity vector. So this is the velocity VQ. Okay, now we know the direction of the velocities VP, VQ and the VC. Okay, now what is given? VC is given. So first write the equation for VC. So V is equal to R into omega. This is the basic formula. So right here VC, this is equal to, now for the point C, radius will be distance CI into omega of the wheel. Okay, for all the points omega will remain same. Now VC is 10 meter per second, distance CI, it is nothing but the radius, and here radius is given which is 0.75 meter. Okay, so this is 0.75 into omega, and from this omega is equal to 10 upon 0.75. Okay, so this is equal to it is 13.33 radian per second. So this is the angular velocity of this complete wheel. Okay, now consider the point P. So for the point P, we can write Vp, this is equal to R into omega. Now here R will be distance Pi and omega will remain same. So this is 13.33. Okay. Now our aim is we should find out the distance Pi. Okay. So consider the triangle PCI. This is a point P. This is center point and this is the ICR point. CP is nothing but the radius, so that is equal to 0.75. CI is also radius, so it is 0.75. To get the Pi, just use the Pythagoras. So Pi square is equal to 0.75 square plus 0.75 square. Okay. So from this we can find out the distance Pi. So this is 1.061. So this is the distance Pi. Now put this value in this equation and calculate the velocity Vp. So Vp is equal to 1.061 into 13.33. So this is 14.138 meter per second. So this is the velocity of the point P. And last we have to find out the velocity of Q. Okay, so Vq is equal to R into omega. Now here R is distance Qi, this total distance. So distance Qi into omega is 13.33. Okay, now this Qi is nothing but the diameter. Okay, so just write here 0.75 into 2. So this is 1.5. So distance Qi, this is equal to 2R. So this is 2 into 0.75. So this is 1.5 meter. Okay, into 13.33. So this is velocity of point Q. So this is 19.995 meter per second. Okay, so in this way we can find out the velocity of any point on the wheel which is rolling on the ground. Now refer this third problem. So here two objects are connected. One is the cylinder or the wheel and second object, it is the rod. They are connected at the point A. Okay, now here motion is given to the end point of the rod AB. So it has a velocity Vb which is 2 meter per second. It means the point B is sliding on this vertical wall with the velocity 2 meter per second exactly in the upward direction. Okay, now just imagine if the point B moves in the upward direction, this wheel or cylinder, it will try to roll in this direction. Okay, and because of this rolling motion in the clockwise direction, the point A, it will move on the right side. So its velocity will be exactly on the right side. Okay, so the question is, if the end point B of the rod AB moves up with the uniform velocity of 2 meter per second, find the angular velocity of this cylinder. Means we have to find out this omega, angular velocity of the cylinder, if the cylinder is rolling without slip. Okay, so this condition is without slip. It means that the ICR of the cylinder or the wheel is located at this contact point. Okay, now this system has a two ICR. One ICR is for rod AB and second ICR is for the cylinder. Okay, now to locate that ICR, draw the given diagram. Now here for the rod AB, velocity of point B is given. So draw that velocity vector. So this is the velocity vector of the point B. Now as the point B moves in this direction, you can see here, as this point moves upward, second end point, it will move on the right side in this direction. Okay, means point A, it will move on the right side. So draw the velocity vector of the point A towards right. So this is VA. Okay, now locate the ICR of this rod, because ICR for the rod, it has two types of motion. This is the rotation. Okay, at the same time point B, it moves in the upward direction like this. Okay, so draw the perpendicular line to the velocity vector VB. Draw perpendicular line to the velocity vector VA. Their intersection point is the first ICR, so take this as I1. Okay, and second ICR, it is for this cylinder or the wheel, and that ICR is located at this contact point. So this is the second ICR, which is the I2. Okay, now here VB is given, which is equal to 2 meter per second. From this VB, we have to find out the VA, and from VA we can find out the angular velocity of the cylinder, that is the omega. Okay, now here we will write the equation for VB. So V equal to R into omega, this is the basic equation. So VB, this is equal to, now here radius for the point B, this rod AB is rotating about the ICR. So for the point B, distance BI1, it is the radius into omega of the rod AB. Okay, now here VB is given, which is equal to 2 meter per second. Distance BI1, it is unknown, and omega AB is also unknown. Okay, but from the given dimension we can find out the distance BI1. Okay, this length is given, which is a 1.5 meter, and this angle is given. So this angle, this is 25 degree. Okay, so as this is 25 degree, this is also 25 degree. These are the alternate angles. Okay, so this is 1.5. If I consider this triangle BI1A, we can use the cosine, and from that we can find out the distance BI1. Okay, it is just a simple trigonometry. So this is 1.5 cos 25. Okay, and distance AI1, this is opposite side in this right angle triangle, because this is exactly 90 degree. Okay, so this side AI1, this is 1.5 sine 25. Okay, so just by using simple trigonometry we can find out these two sides. So BI1, this is 1.5 cos 25 into omega AB, and from this omega AB is equal to 2 divided by 1.5 cos 25. Okay, so omega AB is equal to So this is 1.47 rad per second. So this is the angular velocity of this rod AB. From this angular velocity, find out the VA. So now write the equation for VA. VA is equal to R into omega. Now here R, which is the radius for the point A. So distance AI1. So distance AI1 into omega of the rod AB. So this is a VA. Okay, now here AI1 is 1.5 sine 25 into omega AB is 1.47. So this is 0.93 or 932. So this is velocity of the point A. Now once we get the velocity VA, Next calculation is, we will consider now wheel or the cylinder, and then we will find out this angular velocity omega. Okay, now consider this point A. It is the part of this rolling wheel or rolling cylinder. Okay, so for the point A, velocity vector is a VA, and here the center of rotation, it will be point I2, which is the ICR of the wheel. Okay, now consider the motion of wheel. Wheel or cylinder, and now write the equation for VA. So VA is equal to R into omega. Okay, now VA, it is already known, it is 0.932. Just we have to change this radius and this omega. Okay, now as the point A, it is the part of this wheel, means we have to consider this as a radius. So distance AI2, so this is the radius, into omega for this cylinder. Okay, now distance AI2, it is nothing but the diameter. Okay, so here diameter is already given, phi is nothing but diameter, it is a 0.5 meter. So this is 0.932.5 into omega of the cylinder. Okay, and from this find out the angular velocity of this cylinder, which is 0.932 divided by 0.5. So this is 1.86 radian per second. Okay, so this is how we can solve if the problem is a combination of two objects. One is a wheel and second is the rod. Okay, so whenever there is a combination, it will have two different ICRs. One is for the rod and second is for the wheel. And always remember, for the wheel, ICR is located at the contact point.